In 2a, we will have to find the change in the period of the pendulum if the original length is 4 feet. For this, we will need to find L1 and L2. L1 it's 4 feet, which is already given by the problem, and L2 we will have to find it by a 1.5% increase in L1, which is 4.02 feet. After that, we will have to find delta T. Delta T is the difference between L2 and L1, placed in the formula given in the problem. So delta T it's 2 pi times the square root of 4.02 over 9.81, which is a gravity deceleration, minus 2 pi times the square root of 4 over 9.81. That said, we can see that delta T it's 4.02215 minus 4.01213, which it will give us an answer of delta T equals to 0.01002 seconds. In number 2b, we will have to find the percentage of the change. To do that, we'll put our 4.01213, which is our T1, over 100. That equals to 0.01002, which is our delta T over x, and then we cross multiply. That will give us an x of 0.25%, which means the percent of change is 0.25% increase. In number 2c, we will need to find the approximate percent change in the period. For that, we will need L1 and delta L, L1 being 4 and delta L being 0.02. Then we're going to use our formula, which is dy equals y prime times dx. So we're going to need to find the derivative of our original formula, which is 10 pi over 3 times the square root of 109 times L, all that times dx. So we place that in our formula and then place the values, and it will be dy equals 10 pi over 3 times the square root of 109 times 4, and all that times 0.02, which will give us a final answer of dy equals 0.01003. In number 2d, we will need the result of number 2c. Then, we will have to find the approximate error in this pendulum clock in 1 day. To do that, we will need delta t, which is 0.01002, and dl, which is the same as delta l, which is 0.01003. Then, we know that the error equals to delta y minus dl. Then the error equals to 0.01002 minus 0.01003, which will give us an answer of error equals to -1 times 10 to the power of -5. This is an error because delta t is an exact value while delta L is an approximation. The larger the dl, the bigger the error.
In the following video, I will teach you how to do problem number 7. First, you will have to find your u and your du. Then place your problem into a du function. Leave only the -2 over 3u to the 5. Then you will have to add 1 to the exponent. In this case, 5 plus 1 equals -4. Then you have to move the exponent into the division. Multiply 3 times -4 equals -12, and then -2 over -12 simplifies into 1 over 6. Then you have to replace the u by the original u. That means 1 minus 4x. And at the end you have to add a plus c because you don't know what could you have at the end, at the beginning. And that is your final answer.